Hello, this is Ms. Ahmed, and this lesson will show you how to solve problems with the Pythagorean theorem. In previous lessons, we learned how to use the Pythagorean theorem, a squared plus b squared equals c squared, in several ways. We used it to find the length of the hypotenuse, if that side was unknown, to find the length of a leg of a right triangle, if that side was unknown, and to decide if three numbers could form a right triangle or not. There are many right angles in real life, and there are many real-world problems that can be solved using right triangles. For example, televisions and computer screens are often measured and sold by their diagonal length, not the length of their height or width. So if you need to know how wide or tall they are, you can use the Pythagorean theorem. Say your uncle wants to buy a 70-inch TV, and he needs to know how tall it is. If the width is 59.5 inches, what is the height? You see on the right, we have a picture of the TV on the stand, and the diagonal and the height and width are labeled. But sometimes you might want a simpler picture, like the rectangle below, where we put in the actual dimensions. So the diagonal is 70 inches, and the width along the bottom is 59.5 inches. And we need to know the height from top to bottom to see if it will fit in the place where he wants to put it. I'm going to label the one that looks like a rectangle, A, B, and C. The diagonal is always the hypotenuse, C. The width, I know, is 59.5 inches. And the question is, what is the height along the side? So I've labeled that A. Since the height is a leg for the right triangle, we need to subtract. A squared equals c squared minus b squared. When we have our diagram, it's easy to see the numbers we need to substitute: 70 squared for c squared and 59.5 squared for b squared. We use our calculator to square the numbers and subtract. We get 1359.75. And you'll use your calculator again to find the square root of that, which is approximately 36.9 inches. And you would probably just tell your uncle the TV screen is about 37 inches high, because 1/10 of an inch probably won't make much of a difference in real life. But make sure you use the word about, because this is an approximate answer. Another kind of problem with right angles is a ladder problem. Here we have Ariana, who placed a 20-foot ladder against the side of her house, 6 feet from the outside of the wall. The question is, will the ladder reach the second-story window, which is 16 feet above ground? Now, this picture looks very realistic, but when you're solving a problem, you may want a simplified diagram. So you see here on the right, we've drawn a simpler picture. The ladder is our hypotenuse because it's moving diagonally, and the wall on the right, the ground underneath. And if you were drawing it, you really don't have to make a brick wall or a sidewalk with tiles like you see in this diagram. Just a simple triangle will do. The right angle will always be where the wall and the ground meet. So the ladder is the hypotenuse. In this case, the ladder is 6 feet from the outside wall. That's the distance at the bottom, because of course it's touching the wall at the top. So B is 6 feet. We want to know if A is at least 16 feet, because we need to reach something on the wall 16 feet high. Since the wall is the leg of the right triangle, we're going to subtract again. A squared equals c squared minus b squared. And we'll just substitute the numbers we already have, 20 squared for c squared and 6 squared for b squared. When we subtract, we get 364. And when we take the square root, we get approximately 19 feet. So 19 is definitely more than 16. So the ladder will reach even higher than the second-story window. In fact, they might want to pull the ladder back a little bit if they need to reach exactly. It's not quite clear from the story, but we know it will reach at least 16 feet because it's going up to 19. Distance problems can also be solved using right triangles. In this story, we have a van which traveled 21 miles directly north from the airport, then turned west and drove 28 miles to drop off a passenger. And the question is, how far is the van from the airport? Well, we know that it traveled 21 miles plus 28 miles, which is 49 miles. But it didn't take a direct route. It was traveling on the roads. So the question is really, how far is the van if you didn't have to take the roads? If you want to know the exact distance from the drop-off point to the airport. You might want to draw a picture also for this with a compass rose and the directions north, east, south, and west. So traveling 21 miles north, I would draw a vertical line going up. 28 miles west, I draw a horizontal line. I don't have to measure 28, I'm just drawing a little bit longer than the 21 miles. And I'll label those A and B since they form a right angle where we make the turn. The question is, what is the distance from that final point to the beginning at the origin, C? So here we're trying to find the hypotenuse. So we use a squared plus b squared equals c squared and substitute 21 and 28 for a and b. When we do that, we get 441 plus 784, or 1225. When we take the square root of 1225, we find that c is 35. So the distance from the drop-off point to the beginning airport is 35 miles. And sometimes we use the phrase as the crow flies, because this is the distance if you could fly from the airport to the drop-off point. You didn't have to take the roads. Sometimes they'll just say if it was a straight line distance instead of making two different legs, north and west. In summary, the Pythagorean theorem can be used to solve problems in many real-life situations. Drawing a simple triangle to model a situation will help you decide if the missing information is the length of a leg or a hypotenuse.